Okay, good morning. Good morning, everyone. Yesterday, previously, we have studied chapter number one, that is the matter in our surroundings. So, from that, what we have understood that matter is actually that is having space, volume, and mass. After that, in this chapter, we'll be studying about is matter around us pure? Is matter around us pure? So, when we talk about purity, in our everyday life, we use the word pure in different ways. Like when we go to the market, we purchase this milk, the grocery items. We say that it's pure water, pure milk, pure salt, etc., etc. But when we see from a scientific standpoint, the thing is actually not exactly pure. For example, milk. Milk is not exactly pure when we say that it's a pure milk because it is having fats, proteins, water, so many items. So the topic itself says what is pure then? What is pure? What is the concept of purity? The concept of purity is actually the matter. It should have the same type of particles. For example, iron. So iron we can call it is pure because it's having the same type of particles. And when we talk about silver, say one more example, silver is also it's pure. It's also having the similar type of particles. Another example I would like to give is, say for example, the table salt. The table salt is made up of sodium and chloride, but the sodium and the chloride are bonded together. The sodium and the chloride are bonded together. That is why you cannot, they are even throughout. So another example is sugar. The sugar is also an example of purity. Now we have understood what is purity. Purity is when there is a similar type of particles in a substance, then it is pure. Now we'll move to the impure part. What is impurity? When different type of pure substances are mixed together, it is impure. Now, when different type of substances, for example, let us say, uh, when we prepare a tea. So inside a tea, there's the sugar, there's the tea leaves, there's milk, there's water. So it's something impure. Often we eat those available namkeens in the market in a mixture form. They are also having different type of contents. So we can call it impure. That is that is impure. So the concept of impurity is when different pure substances are mixed together, it's impure. So pure and impure. Pure when same type of substance, when the substance is having same type of particles, it's pure. When the substance is having different type of particles and they are mixed together, so that is impure. Now we'll move to the next part. We'll move on to the next part, that is mixtures. Now whatever is impure, we'll call it as a mixture. Now we will not use the word impure, we will use the word mixture for it. Okay? So pure and impure. Impure is substance and impure is different substances mixed together. It is impure. Now we'll move to the new definition of mixture. Mixture is something which is impure, different substances mixed together. Moving ahead, there are different type of mixtures. There are two basic types of mixtures. First one is the homogeneous mixtures. Homogeneous mixtures is having the same configuration, the same what you call consistency throughout. For example, a Nimbu Shikanji, for example. A Nimbu Shikanji is actually is having the same taste throughout. How do you prepare a Nimbu Shikanji? You take a glass of water, you take a lemon, you put the lemon juice into the glass of water, and you put the sugar into it, and you mix it and you stir it till the consistency becomes even. Now, when you sip the Nimbu Shikanji, with every sip, you will find the same taste throughout. This is the concept of purity. Okay, this is the concept of homogeneity. Homogeneity means same consistency throughout. You may not feel that one sip is more sweeter than the another sip, or the previous sip was less sweeter than the next sip. So there is the same consistency throughout, then it is a homogeneous mixture. Another example is heterogeneous mixture. Now, heterogeneous mixtures, the consistency is variable throughout. For example, let us say a mixture of oil and water. When you mix oil with water, the consistency is not same throughout. When oil is mixed with water and you shake the and you make it a solution, then it is not a consistent solution. Somewhere oil is there, somewhere oil is less, somewhere oil is more. So it's a heterogeneous solution. Another example, another example is sorry, chalk powder and water. When you mix the chalk powder, when you crush the chalk and you mix it into the water and you shake it, and you leave it, you will see the consistency is not homogeneous. Somewhere it is down at the bottom, there are more chalk particles. When you move up, the chalk particles are less. So there are two types of impure mixtures. Sorry, two types of impure substances, two types of impure matters. Impure matters are called as mixtures, and mixtures are called as are divided into further two subcategories as homogeneous mixtures and heterogeneous mixtures. Homogeneous, same consistency; heterogeneous, variable consistency. Now we will move forward to the next portion of this chapter, that is the solutions. So homogeneous mixtures are called as solutions. Homogeneous mixtures. First was substance. Whatever is pure, we call it as a substance. What is impure, we call it as a mixture. There are two types of mixtures: homogeneous mixtures and heterogeneous mixtures. Now we will move on to the subcategorization of the homogeneous mixtures. Example of homogeneous mixtures is a solution. So the Nibu Shikanji is a solution. Solution when the consistency is homogeneous throughout. When the consistency is homogeneous, it's called as a solution. But the solution, how do we identify the solution? We will identify the solution on the basis of few properties of the solution. One, one example, the few properties of the solution. Another example of the solution will be, let us say, a salt and water solution. When you take a tablespoon of salt and you put it inside the water, the solution is a homogeneous solution. Okay. Now let us define this word solution. So solution is that is having solute and solvent. Solution is that which is having solute and solvent. Solute is that which is in lesser quantity, which is getting dissolved, and solvent which is in larger quantity, which dissolves the solute. So that will be a solution. Okay. So solution is having basic properties. First thing is it is homogeneous throughout. The particles you cannot see with your naked eyes. Naked eyes means without a microscope, without any help of magnifying glass, without any aid, you cannot see the particles of a solution. Second thing, it does not show scattering of the light. This is known as Tyndall effect. To elaborate the Tyndall effect, I'll explain you the Tyndall effect in the next part. It does not show the scattering of the light. When you take a torch and you put it across the glass of the solution, the salt and the water solution will not show the scattering of the light will not be seen. The particles are small and it is homogeneous throughout. And the fourth property, physical processes are not capable to separate these solutions like filtration, decantation are not capable of separating these solutions. When you leave it like that and you put a salt into the water and you stir it and the salt is dissolved, when you leave it, you will not find that the salt is settled down to the bottom of the glass. So these are the four basic properties. It is homogeneous. You cannot see it through your naked eyes. It does not show Tyndall effect, that is the scattering of the light. The particles are not visible. And the fourth part, physical processes cannot separate these solutions. Now I'll explain you what is the Tyndall effect. Very often, inside a closed dark room in your own houses, you might have seen the light is entering through the windows and the ventilators. And when the light is entering through the windows and the ventilators, you will see the dust particles are floating into that. You can easily see the dust particles are lighted up. This is the scattering of the beam of the light, and this process is known as the Tyndall effect. Okay. Now we'll move on to the next part of this chapter. Okay, one thing more is left. That is the saturation of a solution. Saturation of a solution. Let me explain. When the rasgullas are prepared at home or during any festivities, there's a sugar solution, the sugar syrup is being prepared. The sugar syrup is being prepared. So, how it is prepared? We take the water, we put sugar into it, and we keep on stirring it, and we apply heat from the bottom. So, actually, the solubility of a solute increases with the temperature. You take a glass of water, you put 5 teaspoons of sugar into it, you will be easily able to dissolve it. You put another 5 tablespoons of sugar into it will take a little more time. And you put another 5 teaspoons of sugar into it, it may be difficult to dissolve the sugar. But you start heating that glass of water, the sugar will be easily dissolved into that. So this is the solubility. Solubility will increase with the temperature. Okay. So now next comes the saturation. Saturation is when the solvent cannot take up more solute. Solvent अपनी capability से ज़्यादा solute hold नहीं कर सकता है. Actually, solvent is having, we have studied in the first chapter that matters particles are having spaces between them. So when you dissolve the solute into the solvent, the the particles of the solute go and occupy those spaces. So it's limited, the space is limited. So saturation is at a particular temperature fixed. When you start heating, the saturation changes. So what is saturation? When the solvent cannot take up any more solute, then that is saturation. So first was the solution. What is solution? The solute plus the solvent. What is solute? That which is in less quantity. What is solvent? That is which is in more quantity. What is solubility? Solubility is the ability of the solute to get dissolved, the amount of the solute that is getting dissolved inside the solvent. And what is saturation? Saturation at a particular temperature when the solvent cannot take up any more solute, then it is saturation. Now we will move on to the Tyndall effect. Tyndall effect I have already explained. Now we will move on to the next part, that is the heterogeneous mixtures. Excuse me. Now we will move on to the next part, that is the heterogeneous mixtures. In the heterogeneous mixtures are categorized into further two subcategories. The first one is the first one is oh, give me a second. The first one is a colloidal solution, and the second one is a suspension. So we'll move on to the colloidal solution. So what is a colloidal solution? Very easy. It's let us the example of colloidal solution is milk. Milk is an example of colloidal solution. Milk is having uneven consistency. You will see that the cream part is at the top. When you heat the milk and you leave it, the cream part is at the top of that vessel in which the milk is boiled, and the fats part. Cream is actually the fatty part, and you see the uneven consistency in the vessel in which the milk is kept. That is an example of a colloidal solution. Now, what are the properties of the colloidal solution? You cannot see the particles with the naked eyes. You cannot see without the help of any magnifying instrument like microscope. You cannot see the particles. The particles are too small. The second thing is that it shows Tyndall effect. The solution does not show Tyndall effect. The colloidal mixtures shows Tyndall effect, but you cannot see the particles. The consistency is heterogeneous. The consistency is heterogeneous, and the fourth part, you cannot separate them by the simple process of filtration. You cannot separate them by the simple process of filtration. If you put milk into you take a funnel and you put a filter paper around it, and you start pouring milk into it, you will find that milk only will come out. You will not find that the fat particles are stayed at the back, or you will not find. The consistency is uneven, but you will not be able to find out. So the different processes are used to separate that. That may be centrifugation and all those processes. We will be studying it in the next part of this series. Now we'll move on to the third part of this, that is a suspension. Example of a suspension is a chalk powder into a water. A chalk powder into a water. So what is a suspension? Suspension, the solute particles are visible. They show the Tyndall effect, the scattering of the light. Okay, the solute particles are visible with the naked eyes. They show Tyndall effect. Third part, the consistency is heterogeneous, and the fourth part, they can be separated by simple processes. Example, filtration. Filtration can be used if you leave the chalk powder and the water. You keep the heterogeneous mixture of the chalk powder and the water. If you let it settle down for a few minutes, you will find that the chalk particles are settled down and the water is at the top. This is an example of a suspension. So what we have studied till now, we have studied what is the concept of purity. Purity is something which is having the same type of particles inside it. When a substance is having similar type of particles, example is iron, example is silver, example is salt, example is sugar, the particles are same. Next is the concept of impurity. When different substances are mixed together, when different pure substances are mixed together, it becomes a mixture and we call it as impure. Okay, air is an example of a mixture. Air is an example of a mixture. There are different type of gases. Okay, there are different type of gases mixed into the nitrogen is there, oxygen is there, carbon dioxide is there, and so many gases are there. Okay, so impure is mixture, pure is substance. The next is, we understood that the type of the mixtures, there are two types of mixtures, homogeneous and heterogeneous. Homogeneous mixtures are called as solutions, and heterogeneous mixtures are further subcategorized into two categories. The first one was the colloidal, and the second one was a suspension. The Tyndall effect was not shown by the solutions. Tyndall effect was shown by the colloidal solution. Tyndall effect was not shown by the solutions. Tyndall effect was shown by the colloids and the suspensions. The particles were not visible in the solution. The particles were visible in the suspension but not visible in the colloids. The third part is, the consistency is homogeneous, the consistency is heterogeneous, the consistency is heterogeneous in the colloids and the suspensions both. And the fourth part, You cannot separate by the solutions, you cannot separate by the simple processes like filtration. You cannot separate the colloids by a simple process like filtration, example is milk. But you can separate the suspensions by filtration, example is chalk powder and water. So we have studied this. This is the first part of the series. We have understood these many things. When we will be meeting in the next part, we'll be covering up the different the processes, the physical processes and the chemical processes by which we can separate these impure substances, impure mixtures that can be that there are so many: evaporation, filtration, fractional distillation. We'll be covering up those in the next part. Hope you have enjoyed this lecture. Okay, thank you. Goodbye.